Hey, welcome. Today, we're going to dive into some really cool stuff from Google Cloud. Basically, the architectural blueprints for building genuinely intelligent AI agents.
So let's get right into it. We've all seen AIs that can chat with you or summarize a document. That's cool. But the real leap forward, the thing that changes everything, is what's called an agentic AI. That's an AI that can actually take action on its own, use tools, and figure out how to solve complex problems step by step without you holding its hand.
And you can't just stumble into building something like that. I mean, you wouldn't build a skyscraper without a blueprint, right? It's the same idea here. These agent design patterns, they're the essential plans. They give us a solid framework for how these AI agents are going to think, act, and even work together.
Okay, so let's start with the most basic building block, the single agent. You can just think of this as your solo AI specialist. It gets a job, and its mission is to see that job through all by itself.
This pattern is absolutely perfect for tasks that are pretty well defined, even if they have a few steps. Like a customer service agent that has to go look up your order status in a database. Or maybe a research assistant that needs to call a few different APIs to pull together a summary of the day's news. It's one agent, one goal. Simple and effective. But how does a single agent actually think its way through a problem? Well, a really popular method is a pattern called react. It creates this really powerful cycle. First, it has a thought. Okay, what's my next logical step? Then it takes an action based on that thought, like using a specific tool. Finally, it makes an observation. It looks at the result of its action. And that new piece of information feeds right back into its next thought. It just keeps repeating that loop, thought, action, observation, until the job is done.
But look, a lone worker, no matter how clever, is eventually going to hit a wall. When a problem gets really big or needs a whole bunch of different specialized tools, a single agent can start to get confused or just bogged down. For the truly complex stuff, you're going to need more than a solo expert. You're going to need a team.
Which brings us to multi-agent systems. The whole idea here is actually pretty intuitive. It's all about decomposition. You take one massive objective, you break it down into smaller, bite-sized subtasks, and you hand each of those tasks to a specialist agent that's built for that specific job.
Now, some of these AI teams work just like an assembly line. First up is the sequential pattern. It's exactly what it sounds like. Agents work one after the other in a strict, predefined order. It's super efficient for things like data processing pipelines, but it's not flexible at all. Then you've got the parallel pattern. This is where multiple agents get to work at the exact same time on different things. It's way faster for tasks like gathering information from a bunch of different sources. But yeah, as you can see, firing up multiple agents at once is going to cost you a bit more.
But what happens when the job isn't a neat, predictable assembly line? What if you don't know the exact steps ahead of time? That's where dynamic patterns come into play. These systems behave less like a factory floor and a lot more like a project management team that can think on its feet.
With the coordinator pattern, you have a central manager agent. Its whole job is to look at a new request, figure out what needs to be done, and then delegate the work to the right specialist agent. Like a smart customer service router. Then, for the really huge, fuzzy, open-ended problems, you have the hierarchical pattern. This is like having a CEO agent who breaks a massive goal down for their director-level agents, who might then break it down even further for their own teams. It's incredibly powerful for complex planning, but as you can imagine, building that kind of management chain is a lot more complex.
All right, now let's talk about patterns that are less about just getting a task done and more about quality, refinement, and creativity. You can think of these as the creative workshops of the AI world, built for jobs that need a few drafts and some solid feedback to get right.
This one is basically an author and editor partnership. You have a generator agent that creates something, let's say it writes a piece of code. Then a critic agent comes in and reviews that code against a checklist of rules, maybe looking for security flaws or style issues. This back and forth loop continues until the output is top-notch.
So the huge benefit here is that you're baking a quality control step right into the process. But of course, there's a trade-off. Every time that critic agent has to review the work, that's another call to the AI model. That means more time and more money. So you're basically trading speed and cost for higher quality and reliability. It's a classic choice you have to make.
And finally, we get to the most sophisticated and honestly, the coolest pattern, the swarm. In a swarm, there's no central boss. Instead, I want you to picture a brainstorming session with a team of human experts, maybe a designer, an engineer, a marketing lead. They're all in a room, talking directly to each other, sharing ideas, debating trade-offs, and building on each other's work to come up with a solution together. That's a swarm.
This approach is amazing for incredibly complex or creative challenges, like designing a brand new product from scratch. It can lead to some truly innovative solutions that no single agent could ever come up with. The catch? It is by far the most complex and expensive pattern to build. You need some really smart logic to manage all that conversation and make sure the agents are actually making progress and not just arguing in an endless loop.
Okay, so no matter how brilliant your AI team is, whether it's an assembly line or a creative swarm, some decisions are just too critical to leave entirely up to an algorithm. For those times, you absolutely need a human in charge. And this pattern gives you exactly that. It's essentially a pause button built right into the AI's workflow. The agent will work autonomously up to a certain critical point, and then it just stops. It waits for a person to come in, look things over, maybe make a correction, and give the final go-ahead before it's allowed to continue. This is non-negotiable for high-stakes stuff. I'm talking about things like approving a massive financial wire transfer, or deciding to launch a marketing campaign, or anything where a mistake would have serious, real-world consequences. It's the best of both worlds. You get the speed and efficiency of automation, but with the safety net of human judgment right where it matters most. All right, so we've looked at the lone worker, the assembly line, the management team, the creative workshop, and the human supervisor. That's a lot of options. So the big question is, how on earth do you choose the right blueprint for your project?
Well, how do you pick? It really all boils down to asking yourself a few key questions about what you're trying to accomplish. According to the source material, your whole decision should really hang on 4 main criteria.
First, what's the nature of the task? Is it a straight line, predictable process, or is it more open-ended and messy? Second, what do you care about more, speed or accuracy? Do you need an answer right now, or is it okay to wait a little longer for a better, more polished result? Third, what's your budget? Remember, more agents and more review loops mean more calls to the model, and that costs more money. And finally, and this is a big one, does this task need a human to sign off on it at any point?
And you really want to think through those questions carefully, because as this quote makes crystal clear, picking an agent pattern isn't just some minor implementation detail. It is the fundamental architectural decision. It's the foundation that your entire intelligence system will be built on. And as these systems get more and more sophisticated, evolving from simple tools into what look like collaborative teams, it leaves us with a really fascinating question to think about. In the near future, will our main job be to program AI or to manage it? It really seems like our role is shifting from being a coder to being more of an orchestrator, a manager of intelligent, autonomous teams. Thanks for watching.